Okay, I have a question, but I'm open it up to the floor because our question is, if you wouldn't mind, please, I hate to ask this, but please go to the microphone so that your question can be heard on the videotape.
Yeah, mine is fairly general. Amongst all of you, Thomas, you mentioned the Industrial Internet Consortium, and actually in your presentation, I saw a blurb. So a question I have is, in the Industrial Internet Consortium, which I'm part of, they've come up with what's called the connectivity framework that talks about interoperability between different IIoT networks. And within that, they've identified core standard, what I call core connectivity standards that provide this notion of syntactic interoperability. And one of the core standards is OPC UA. Now, when I heard you, and the other one is DDS, Web Services, and 1M2M. But when I heard you say that OPC UA is actually built on top of DDC, whereas they place OPC UA 1M2M as a core standard that provide only syntactic, not actually semantic interoperability. Just want you to comment on that a little bit, if you could.
Okay. Yeah, got it.
Thank you. Thank you. That's a very good question. So deliberately, when we started thinking about your question specifically, my goal is about interoperability. My goal is about information integration. I don't care about all these other protocols, and what we do, though, is I do care about them because we look at all these protocols, and we basically, I'll call it a binding to the protocols. For example, I have a very tight partnership with a company called RTI. RTI is very involved in the DDS. Yeah, Dr. Stan Snyder are best of friends, okay? You know, we have dinner every time we have a chance to get together. But the opportunity is we recognize that the DDS technology and the OPC UA technology clearly have value for different models, different use cases. But we also recognize there was an opportunity for us to partner together. So specifically, you know, OPC UA has a partnership deliberately where we've actually built, well, first gate was we built some gateway products, okay? And the gateway products basically demonstrate the capability of having, you know, DDS things be able to talk to OPC UA. But in addition to that, we're taking OPC UA and actually supporting DDS as a native protocol inside of our transport. So DDS or AMQP or MQTT are communication protocols in an OPC UA framework. And because of that, I can take, and you know, this sometimes scares people what I'm about to say, but now I can take a device over here that understands MQTT, and I can take a device over here that's DDS or, you know, some other protocol, and with OPC UA, I can make these things talk together. And that's what we're trying to do. And not only can we make them talk together, I can make secure information between these things. We're doing the same thing specifically with, like, that was the whole premise behind FTI and what we did there. I wanted to take a Siemens controller, and it should only always be Siemens, but I wanted to make a Siemens controller talk to a Rockwell controller, but be able to talk to it in a way that there wasn't anything in the middle. So they natively can communicate together, and because of the collaboration we've done specifically, I can actually take information from this side in a secure fashion, and the other side understands it. That's what we're doing in the IIoT world. So we bridge on top of that. We provide, well, you know, MQTT and, you know, DDS, they're at the communication layer. If you take a look at the ISO model, we provide the session and the application layer on top of that, giving secure information. At the same time, well, God, that's got to be a lot of overhead. Let me tell you about all the people that have put UA in very small, you know, in silicon. Okay, it's very scalable deliberately for reasons. So. My friends at ARC, for example, they just did this analysis of the adoption of the technology. And one of the things they did is when we first did this with the ARC guys, it looked like we were going to be around, I guess, 47 million installations with OPC. But now what the ARC people are telling me through the extrapolation, because of what we're doing IIoT, by the end of 2018, we'll be at 120 million installations. So it's because of exactly the question you asked. UA becomes the information, secure information architecture on top of the IIO2 protocols like DDS, AMQP, MQTT, HTTPS, and there's 26 more. Okay, thank you.
we have time for maybe one or two more questions, if there are some from the floor, please.
Okay, just a very quick question. So we have so many companion standards. What if some of the different models, they have some overlap part, for example, in different contexts, like Mimosa in asset context, like MD Connect is from machine tool, a runtime data stream. So how, you don't want to in your device, you using two sets of different model and create two different objects for that instance. So how are you going to harmonize this?
I'll let Paul answer this one.
We actually,
In the bits and bytes.
we actually work on that all the time. So that, it's not unusual that we have more than one organization that wants to come up with a model, and we look at the models and realize they overlap a lot. So we try to get the organizations to work together more often than not. So PACML, for an example, right? There's Weinstefan, which is a different packaging standard. They're very similar. Matter of fact, they're about 80% identical. So we wrote a PACML companion standard. Weinstefan wants one. We're getting them to join the same companion group. So we're going to work out that we have one standard that supports Weinstefan, PACML. Same thing with MT Connect. We're working on that one again to synchronize them with the VDMA. We're a neutral organization. It's amazing how many of these other organizations that don't usually get along are willing to work with us and get together and create a single standard. We try to work it out. Doesn't always work, but we do try to get them to agree to something that's a common model, because they almost always do have a commonality behind them. Some cases we extract the common pieces into a base model then and let them base their differences on their own, but then it's just the differences. So we try to make sure we map things in a uniform way. Does that answer your question?
And maybe you remember my slide regarding VDMA, where we have, don't ask me, 40, 50 branches, industry segments, machines, tools, and exactly we are on the way how we harmonize this also from the process side. And of course, like you mentioned, the technology and also support from the OPC Foundation is needed and will be established or is established.
Okay, these gentlemen will be around. We are out of time, so thank you very much for your attention, and let's thank them for their enthusiasm and knowledge.